Okay, so this is programming example number one, and I won't remind you on all of the examples here, but since this is the first one, I just want to reiterate that you should not be viewing these recordings and looking at the solution before you actually try to do these programming exercises yourself. You're going to learn to program by working through the problems yourself, even when it becomes difficult and you're stuck. Sort of really working hard and pushing through that is where you're going to be doing most of your learning. The reason I record these videos is so you can get an idea of, after you've tried the problem, how I went and solved it, maybe how that might be different. And maybe you can pick up some tips about how to solve your problems, maybe how to correct some of your bugs that you might have encountered. But you should always be doing these assignments yourself first, and then looking at these as sort of more of a recap and a reinforcement than just sort of going through the exercises of looking at this. All right, so for this exercise, we're just going to be writing a program that asks the user for three different integers and prints out the largest odd number. In addition, if none of the three are odds, if the user types in 246, for instance, we should print out a message that is indicating this. So there's a few different ways of taking this on. First off, let's address the odd number situation. So if I have a value x, and I'm trying to figure out whether that's odd. Let me reduce my font there. If I'm trying to figure out whether that's odd, the easiest way to do that in Python and in many programming languages is to use the modulus operator. A number is odd if you divide by 2 and there is no remainder. So it's odd if this value is not 0. All right, so that's part of this. Let me clear this out. Another aspect to this problem is trying to figure out, well, which is the largest odd number? And if we kind of restate this, let's just think about what's the largest number. How do we find the largest number between x, y, and z? And one possibility is we can just simply enumerate all the options. You only have 3 options, right? So you could write if, let me get rid of those parentheses, if x is greater than y and x is greater than z, then we'd print x. And then we could check if x is greater, or if y is greater than x and y is greater than z, print y. And I'd do the same exact thing for z. I'd see if z is less than or greater than x and z is also greater than y, and I'd be able to tell you specifically which one is bigger. Now, of course, if we throw in this idea of an odd value, things get more complicated because we don't care whether x is greater than y and z if it's even, right? It doesn't count. We also don't care whether x is greater than y if y is even or if z is even. So we don't want to compare any numbers, and we don't want to involve any numbers if they're even. So the way I would solve this is using a little bit of a different approach. Instead of enumerating and having separate if statements for each individual case, I'm instead going to sort of have a running notion of what's the biggest number that I've seen so far? What's the biggest odd number that I've seen? And so let me go back here again. We'll start with this x, y, and z, but I'm also going to have another variable called max odd. And when I start, if x is odd, so let's consider all odd numbers right now. So we have 3, 5, and 1. 3 initially is going to go into max odd. Right? And then we're going to move on to 5, and we're going to say, is 5 greater than the largest number that I've seen? And the answer, of course, is yes, it is. So we put 5 in. And then I'm going to move on. I'm going to look at the 1, z. And I'm going to see whether z is greater than the 2 numbers that I've seen before. But I'm not going to have to explicitly say, is it bigger than the 2 numbers before? I'm simply going to say, is it bigger than my maximum? My maximum already reflects what the maximum was of the first 2. And using that, that could be carried over with 4 and 5 and 6 inputs, right? The sixth value, is it greater than all the ones that I've previously seen? So this idea of using a variable to remember the largest number is one that will help us and it'll allow our code to be a little bit more clean. Incidentally, we can also handle inputs where we've got odd and even numbers. So we could have something like 381, and in this case, the 3 would pop into max odd, and then when I looked at 8, I could simply ignore it because it's not odd, and keep going and now look at the 1. So I'm going to start with that in terms of for our code. So I'm going to get X from the user. Y and Z. And I'm going to have my first condition be if X is odd, so if it's not equal, if mod 2 is not equal to 0, and it's greater than max odd. I'm going to say max odd equals X. And then I can print out, let's print out max odd. So if we run this, right away we see that there's some errors. And the first error, you might have picked up on this while I was typing in the input, is talking about conversion and string formatting. And what you see here is that I'm using a modulus operator, and a modulus operator is only available for integers. Anytime you call the input function in Python, that returns a string, not a number, not an integer. Even though it represents, the string 3, Python's not going to be able to do a modulus operator on it. So the first thing we need to do is remember that in Python we want to turn the input, or we can turn any string into an int by calling the int function. Right? And that does the conversion to an integer. At that point, now Python knows how to do this, right? And it can actually determine whether that number is odd or even. So let's run it again. And we're almost there, but we've got yet another error. And it says max odd is not defined on line 5. If we look on line 5, we're trying to figure out whether it's greater than max odd. That doesn't make any sense because max odd doesn't really have a value yet. So we need to actually initialize max odd to be something, and it should be something that the user is always going to type in something larger than, right? So we'll initialize the maximum odd value to be a really small number. And then that way when the user starts typing in the numbers, the first odd number they type in, it'll be guaranteed to be bigger than this. 0 kind of comes to mind as a good answer. Okay, so 3, 5, 7. Maximum odd number is 3. Of course, we didn't check for Y and Z yet. If I type in 2, 4, 5, maximum odd number is 0 because the maximum odd variable did not get updated. X was even, so it wasn't considered. That's actually showing us what's going to happen if none of our values are odd. If we get all even numbers, max odd's going to always be 0. And now let's fill in all those comparisons now. The Y portion of this will look very similar to the X, and so will the Z. So if I type in 3, 5, and 1, we get 5, 3, 5, or 3, 5, and 7, we get 7, 7, 5, 3. If we type in a couple of odd numbers, or even numbers, we still see that the maximum odd number is 7. If we type in 3, 4, and 8, maximum odd number is 3. But if I type in 2, 4, 6, now maximum odd number is 0, and again, that's highlighting the fact that, well, if all of those numbers are even, we'll never actually modify max odd, and that's where we can check. We can say if max odd is equal to 0, then you did not enter an odd value. Else, we'll print out maximum odd. And now we're good enough to pick that up. So this is a pretty good solution. There is one little gotcha here. And if we test with all the usual suspects for integers, this works very well. But if I type in something like -9, -5, and 4, it comes back and it says I didn't enter an odd value, and that's not true, right? I did enter an odd value. -9 and -5 are both odd values, but since they were not greater than 0, they never got actually updated. Maximum odd was never set to their value. What we really need to do is do a little bit better job in picking 0. 0 is not really the smallest number the user could type in. The smallest conceivable number would be something like -infinity. We don't necessarily usually think about representing infinity in computer systems, but there's always a minimum number that we can represent in the number of bits that are on our system. There's always a maximum number. Thankfully, Python doesn't really require us to kind of think about the binary part. We can actually tell it that we want the smallest possible number that it can represent by converting a special string into a float. Float INF, negative INF, the string negative INF, will create a floating point value, which is the smallest representable value on this system. Right? So I have a 64-bit machine, so really it's 64 bits worth of negative values. If I do that, and I got to update this if statement. If I do that now, the rest of the logic in this code is exactly the same. Nothing really has changed. X will always be greater than max odd. If X is odd, and I actually make it to this comparison, it'll be greater than whatever I initialized. Doesn't make a difference. It's physically impossible for me to type a value that is not greater than this negative INF. Now if I run it with my new inputs, I get the right answer, and I'm still, of course, getting the right answer for the old. Right? And that's what that's how I would complete this assignment.